Hello everybody, welcome back to another episode in Minecraft. In this one I'm going to be showcasing my latest mod. It's a 3D graphing calculator mod, and you can see we've got a lot of blocks over there. I'll get into that in just a minute. A download link will be in the description, by the way, so if you want to download it, take a look at that. First I'm just going to talk about what I'll talk about in this episode. Basically I'm just going to explain the overview of the mod, then I'll go into a little bit more detail about using the graphing calculator, and then I will show off some graphs, some cool graph pictures that I've put together in between that and the end part, which will be me describing how to use the actual function inputting interface, which is a little bit unuser friendly at the moment because this is still pretty early release. I'm actually currently working on a sort of building blocks form of inputting an equation. You have little GUI blocks that you put together into an equation, or at least that's the plan. It's still pretty early stages, but I'll get to that when I get to it, which will be pretty soon. And actually, as a result of currently working on that, I'm not going to show you how to put the equations in until the very end of this episode, because I don't think it'll be hugely useful for you to know how. It's going to become obsolete pretty quickly, even if you do learn it. Now, I am just about to go into detail about how this GUI stuff works, but in fact, each and every bit is explained if you hover over the far end of the text field, so you should probably do that as well, just when you're in game as a reminder. However, let's get started with this overview. So we've got 9 different coordinate systems, as you can see here, and I'll go into a little bit more depth on how to use that stuff a little bit later, like I said in the start. The recipe for one of these calculator blocks is shown here. There's a little empty space in the middle. That's because I was trying to put ingredients that would correspond to the shape of the graph, or the graphing coordinate system. This did not go well. You can see we have a pseudo-random distribution of mildly related items in there, but each one corresponds to the central ingredient for this coordinate system. And once you have one, you can switch between the different variables by putting it into your crafting slot. I should have gotten a crafting table out already to show you that in action, but instead I'll do it this way. So, for example, right here we've got a spherical graphing calculator, r as a function of theta and phi, and if we put it in here we can get phi as a function of r and theta, or theta as a function of r and phi, and then it goes back to r. So that's how that works. And I would show you this recipe, except it's pretty self-explanatory and takes a while to put into the crafting table, so I feel no need to. The only graphing calculator that you cannot see see every variable as a function of any other one in is the Cartesian system, and that's because it looks exactly the same in every permutation there. So you can either just rotate the thing or, mirror it, whatever you want. You don't need an extra block to get the other variables out of that. And speaking of all these different crafting recipes, what can you craft with them? Well, we've got 9 different coordinate systems at the moment, and I plan on adding at least 3 more quite soon. So we've got Cartesian, Spherical, Cylindrical, Parabolic Cylindrical, Bipolar Cylindrical, Oblate Spheroidal, and I'm going to add Prolate Spheroidal, fun fact. Anyway, Toroidal, Conical, and 6-sphere. The other main aspect of this mod is the graphing calculator memory card, and the crafting recipe is shown here. This one doesn't have anything special or weird about it, and I'll show you how to use it in a minute, but you can copy graphs with this thing. So it's a pretty useful thing. You can save graphs like I have in this chest and view them later, so pretty cool. However, that's the overview done, so let's get started with the actual showing off of cool things. First here, let's take the Cartesian graphing calculator over into a secluded location, and we will input a graph that is kind of hard to actually get a good image of, so that I can fiddle with the settings and show you how things are done. I'll do 1 over x for this graph, and you can see here we do get a preliminary outline of the thing. It's currently halfway stuck into the ground, so I'm going to translate it up by about 10 blocks. And there we go. So one of the main things you'll probably notice is that this is, being the graph of 1 over x, discontinuous, and should not be connected right here with this big plane. this is an asymptote that goes up forever and then comes down from forever and keeps going on. So we need to disconnect that, and luckily this graphing calculator mod does indeed do that for you. So this first area here is the domain, the A domain in this case, that would be X, and the B domain is Z, and then the range is minus 100 to 100, and that will be Y in our case. So you can see on every graphing calculator, A and B are defined in the name, so you don't have to worry about which is which, not knowing. And having just upped the resolution to 20, 20 by the way refers to 20 tiles. You can see the tiles are pretty small at this point, 20 tiles per unit. And I don't say per block, even though that's the default size of a unit, because you can scale it. And when we get to that, one unit will no longer be equivalent to one block. So we have trimmed off our asymptote, and we have also achieved a result of very small tiles. So how about we enlarge the grid size so we can see it better by increasing tile count, and this is the positive integer number of segments over which one texture tile is spread. So let's up that to 5. We've got a slightly more readable graph now, and maybe if we up it a little bit more, say to 10, yeah, that looks pretty good. You can see that the texture starts being stretched as the graph increases ever more rapidly, and that's a pretty good indication that your slope's gotten quite high. Another thing we could have done to sever this asymptote is if we go back to sort of what we had before, resolution of 2 and a tile count of 1. The graph is connected there, and we can sever that graph by decreasing the discontinuity threshold. So this is another way of detecting asymptotes, and basically what it does is areas of the graph that exceed this slope are severed. So if we down the number to 5, you can see it no longer connects the 2, and actually it's severed them a little bit early, so we might want to increase that. It can probably handle 20 maybe. Okay, maybe 10. Yeah, that's about right. And that's a good way of getting rid of asymptotes without increasing the resolution a lot, because the automatic detection only severs asymptotes that leave the range. And so if we wanted to not touch the discontinuity threshold but still sever that asymptote, we could decrease the range quite substantially, I might add, and you can see it slightly distorts stuff. That's a less of a problem if you have a higher resolution, and the discontinuity is discontinuous now. I've reverted the graph to what it was before we made those changes now, and what we want to do next is probably just customize it a little to make it look more like what we want. So that might involve changing the RGBA values, the red, green, blue, and alpha. Alpha is opacity, and a higher value up to 255 increases the opacity of the function. I'm going to select a random value here by inputting R, and you can see we get a nice purple. That's a good color. Sometimes you get brown. And I guess another thing you might want to do is scale the graph. So over here we've got the X, Y, and Z scales. These are not connected to the coordinate system you're in. The scaling is done after the graph has been graphed, I suppose you could say, although it's a little bit more complicated than that behind scenes, but that doesn't matter. So let's downscale it so we can see a little bit better. And this does not affect resolution, by the way. You can see we still have a nice, good quality graph there. And if we lower it back down, because it doesn't need to be so high anymore, we've got a sort of table setting. And another thing we can do, save from translate in the X, Y, and Z directions or scale, is we can rotate the thing. And let's try around the Y-axis first. This is in radians, by the way, not degrees. So you can see rotate it around the Y-axis. and it goes counterclockwise around the axis when viewed from the positive end of that axis. So we can also rotate it around the z-axis. There we go. And also the x-axis. Like a not so. Probably don't want to rotate it by an apostrophe. Generally discouraged. There we go. Another thing we can do with these graphs is texture them with whatever block texture you want. So currently I've got the block mesh grid texture on from my mod, but we could also use block mesh flat, another good one. And you can see it's gridless, this one. Just a nice smooth color if you want that. Or we could do any color in Minecraft, and for that we might not want to tint it, so I'll go with 255 for all the RGB values. And the way you input this texture would be Minecraft is the domain instead of my mod ID, which is Graphing Calculator 3D, and the path to the texture you want. So in this case, I'm going to go with blocks and maybe stone. And you can see we've got a stone colored graph now. And like I said, we could tint it if we wanted. Pink stone now. So that's a thing if you want that. And since we're no longer looking at the grid lines, we might want to decrease the tile count, make the tiles a little bit bigger. Of course, you don't have to. Oh, that was exactly the opposite of what I wanted. There we go. Increased, and the tiles are a little bit bigger, the textures are a little bit more visible. To show you a couple other things, this is just the graph of y equals x times z, and if we go in here, you can see the range is quite high. Now, if we didn't want such a high range for whatever reason, then we could lower that maybe to 10, and by default, what the graph does is it will crop the function to the top, which essentially means that it just flattens the top down to the range. Any value higher than the maximum range is set to the maximum range, and any value lower than the minimum range is cropped up to the minimum range. So if you didn't want this, one thing you could do is turn crop function to range to false, like so, and you start getting some spiky things, but it isn't cropped to the top like it was before. Now the spiky things are actually just because we're rendering in square tiles, and those are diagonal corners of our square tiles, if you know what I mean. And if we wanted to get rid of those or lessen their impact, we could up the resolution, which would use more tiles, and so the sharp bits would be less visible, although still somewhat. If you have a horizontal graph, like for example the graph of y equals x, like so, and you want to crop that to the top, you won't get any spiky bits because it's not a diagonal, it's not exceeding the values by a diagonal quantity, or diagonally or something. So nice and smooth up at the top there. Now, if we wanted to copy this pathetic little graph over to that calculator, for example, then, like I said earlier, you would use one of these graphing calculator memory card items. And the way these work is you shift right click, sneak right click, I should say, and it saves the basically all the data inside the graphing calculator over to this card. And then you normally right click, and it will copy all that data onto the other graphing calculator. A nice way of using this is you can save graphs in your chest or something, and you can take a look at them whenever you want later. I'll just show you one more thing before we move on to the other sections that I mentioned at the start of this video. Let's try and make a sphere. And first things first, we need to up the resolution because spheres are kind of tricky to render. Need a lot of tiles. And second things second, you start to notice that there seems to be some texture difficulties there, and that's actually not texture glitching. That's not trashy stitching or anything. What's happening is that we have such a large domain that the textures are being rendered over each other over and over again, and so we should restrict the domain so that only one set of textures is rendered for our sphere. We can do this by restricting the A domain and the B domain. And with this calculator, r is a function of theta and phi. Theta is A and B is phi. So in the spherical system, phi is the azimuthal angle, the angle horizontally, sort of like this, starting at 0 and going counterclockwise, the way I explicitly wasn't turning apparently there. And meanwhile, theta is the other angle, you know, the one no one cares about. It goes from the top down. So because we want a sphere, we only want to go around once for each of those, and that means theta should go from the top down to the bottom to make a nice hemisphere, or hemicircle, I guess, half circle, and then that half circle should be rotated around an entire circle to make a sphere, and no more, no less. So we should not go into the negative direction, because that makes things unnecessarily complicated, and for the half sphere we want 1 pi radian, and this is the A domain, which is theta, so we want exactly 3.14159 to be the maximum A domain value, and 0 to be the minimum. And over here we've got some nice convenient copy-pastable values for you, like pi over 4, pi over 2 pi, 2 pi, 4 pi, e over 2, e and 2e. So let's go from 0 to pi, and that already saves us some of our texture glitching. However, we're still overlapping in the phi direction, and so we only need 2 pi to be the maximum, and we don't need to go around backwards. We've got a little bit of a crack because we have an exact value that's halfway in between these two as the maximum domain, but we're not passing that because the size of our tile is larger than the gap. So we should increase our domain slightly just to get that extra tile. And we can do that by maybe going up to 9 there, and I think 3 generally works pretty well here. So yeah. And we shouldn't have a hole in the bottom either. Very nice, very nice. And there's our sphere. With that out of the way, I will put the graphs up. So now for the unuser-friendly part. This wall of text is what I'm about to explain, basically. So when you want to input an equation, you probably saw earlier some. Oh, I didn't have an equation in. Okay, whatever. You probably saw some gibberish like to add and 0 val, and what that refers to is as follows. So when you want to add a portion of your equation, you will first need to write the number of inner expressions within the evaluation method. So if I want to write the addition of x and z, I would write to add, because there are going to be 2 values inside this add evaluation method, and then 0 val and 0 val for x and z respectively. And so we have 2, which is 1 for each of these values, and then add is what we're going to be performing on those 2 values, and then the value themselves, or the value itself, is a slightly special one. Since there are no inner expressions, just a value, we're going to put it in 0, and then val is the evaluation type, and then we need a pair of square brackets and whatever the value is, and then a comma, and then whether that value is a variable or not. So for x or z, let's put in z here. Z is a variable, so we're going to put in a 1. That's sort of like a true. And then x over here is also a variable, so we put in x and 1 for true. Now if we wanted to write the addition of, well, there you go, by the way. If we wanted to write the addition of 10 and z, then we would put in 10 and 0 because it is not a variable. And I've mucked something up. Oh wait, no, I haven't. It's just up here, translated, right. If we want to write something like pi, for example, we can do that in this. There are several special values which are listed in here along, with all the other evaluation methods down at the bottom. And those would be pi, e, a, b, and c, where a, b, and c are a couple values defined in the config that you probably don't need to care about. However, for pi, we will put that in, and pi is not a number. It's one of these special values, so it needs to be replaced by a number, and so you put in 1 to indicate that. And so we get a slightly lower function. And about here is 3.14159. 2657. Actually, maybe not the 7, I can't remember. Anyway, that's pretty much it for the equation inputting. It's not actually too complicated, it's just not very user-friendly, like I've said. My initial plan was to only use that for data serialization, sending it over the network and saving it to disk and things, but I haven't actually finished with my GUI elements yet, so currently that's what it's being parsed from. And yeah, not fabulous, but it's a temporary solution. So let's do something a little bit more complicated. How about ooh, I didn't think of this. Okay. How about 2 molt, 1, and this is completely arbitrary, don't expect it to look cool. 1 over, and maybe 1 sine, 2 add, and that's probably enough. So this is how I suggest inputting the equations, sort of one by one, filling in the parentheses. If you try and do it all in one long stretch, it's not going to turn out well. You can see I've barely kept onto my train of thought here while talking. But yeah, you should fill it in something like that. Now 1 over maybe pi, and that's a variable, and then the sign of the addition of, say, 3, which is not a variable, and x, which is a variable, and we get some stuff. So that's how the inputting of equations works. Now, say you make an error. Say you forget your L. Well, fear not. It won't wreck your string. If you put in a bad method of evaluation here, it'll replace that evaluation with null, and so you can fix that. Add the L back in. If you miss one of these numbers, for example, it says error invalid function, and sadly it's not quite so helpful. You have to find that yourself. If you don't put in enough arguments, then it'll tell you so, and that one does sort of wreck the equation if you had those arguments, because it thinks that there should be only 1 because that's what you gave it. So yeah, if you don't supply enough arguments, it'll give you an error. Basically, it won't crash if you do stuff wrong, and it probably won't wreck your equation too badly. I think that's pretty much all I have to say for today. Hopefully you enjoyed this episode, and take care. Bye-bye.